This is Geometry, Unit 4, Day 3. We're talking about rigid motion and congruence. Rigid motion are the transformations that we have done earlier. It's about a translation. Transformation is the whole family of different ways to move your shapes. One of those transformations is called a translation. We can slide it. We might be able to rotate it. And in both of those cases, everything's going to remain congruent still. The wheels would be congruent to each other. In brand new cars, windows would still be congruent to each other. It doesn't matter if you've moved the car or turned the car. It stays with rigid motion. Well, the same thing is true for polygons. We're going to take this triangle and we slide it. And as we slide it and move it to a new spot, we'll call it some new letters. GEO. We could trace this out exactly and see that the sides are exactly the same. The angles, the corresponding is what it's called. Corresponding angles will still match up. If we slid this over, angle A would be the same thing as angle G. It would map over to G. Side AB would become side GE. Angle B would become angle E. Angle C, or let's say side CB, would become side EO. Angle C would become angle O. And then side AC would become OG. So the corresponding sides would still all match up. When we do that, there's something called a congruence statement. A congruence statement is when you take the name of a triangle, or any polygon for that matter, but in this case a triangle, and you make it congruent to a second triangle. What's really neat about the way this congruence statement is supposed to be written is that the angles all match up. So angle A and G, which map to each other, should be in the same spot. B and E that map to each other should be in the same spot, both the middle letter. And then CO would be both the last letter. You can write it in a different order. ACB is going to be congruent to triangle GOE. They have to be in corresponding position. Notice that the first two letters AC would match with the first two letters G and O. The last two letters BC would correspond with E and O. And your first two letters AB are going to correspond with G and O. It has to show all of the corresponding parts. You can read that from it's called a congruence statement. Now we could start with letter B, or we could start with letter B and name it differently. If we did that, our congruence statement would adjust a little bit. The B went with the letter E, the A went with the G, and the C the O. The letter B still went with E, but this time C is second, so the O would be next, and then the G. And then finally we could start with the letter C, naming our last set of triangles. These are all the same triangle. Triangle CAB is the same thing as triangle CBA. It's still this first triangle that we've drawn over here. But there's different ways. If we change the order in which we write the name of the first triangle, the second triangle of our congruence statement has to be written in the corresponding order. So what letters go with angle C? O goes with angle C. G goes with angle A. And E goes with angle B. So there are 6 ways that you could write the correct congruence statement for any pair of triangles. There are 6 correct answers for any congruence statement. Typically, we'll only have to write down one congruence statement. On our next page, we're going to look at some rectangles. We're going to plot the rectangle, -5, 1, -5, 5, -1, 5, and -1, 1. So that gives us this triangle right here, or this rectangle. Some might call it a square because it's a rectangle with all equal sides. It's a rectangle because it has right angles in the corners. But this would be A, B, C, and D. They want us to reflect it over the y-axis. So our y-axis is vertical. So we have to go and fold our paper and make the shape fall on the other side of the y-axis. So it's going to flop over to this side. Where would it land? This point would land over there, and we're going to call that H. The A is going to land 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the A point is going to become the M. The C is 1 away from the line of symmetry, so it's going to become 2. It's really our reflection line. And C becomes point T. And then B, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 would be approximately here. And then we have our new figure. And that point, that angle B, becomes an O. So, list all the pairs of corresponding sides and angles. Well, angle A is becoming angle M. Angle B is becoming angle O. Angle C with T. And angle D with H. That means that segment AB is being mapped with segment MO, segment BC is going to be mapped with OT, CD is going to be mapped with TH, and finally side DA is going to be mapped with HM. So there's multiple ways for us to write the congruent statement for this. We're going to specifically write down 2 ways. We're going to look for a way to name our original shape. You can name a polygon in the order, let's call it, not just any order, but in an order that is in a circular pattern. You can start with any letter you want and you go in a circular pattern, either clockwise or counterclockwise. So a typical way would be alphabetical: A, B, C, and D. You start with A, B is consecutive, or it's in a circular pattern to C and D, all the way around. That would be congruent. The A mapped with the M. The B, ABC. The B mapped with the O. and the T, and the H. Notice for a rectangle there is no special symbol that we put before it. For the second congruent statement, you can put it down in any order you wish. You can start with C if you want, then you can go in a circular pattern the other way, C, B, A, D. If so, you still need to start with the O, because the O and the, oh, I'm sorry, not the O, the T. The C and the T correspond to each other. Those are congruent. So T, that starts with our C. The B, then the A value, and then the D value. TOMH. It corresponds to the CBAD. That is a congruent statement. Here we have a rhombus, and we're going to plot a rhombus, 0, 4. We got 3, 8, that's point E. Okay, so this would be G and F. So we labeled our point after we plotted. We're going to rotate it 180 degrees. When we do that, we're going to use the rule of just changing the signs. So our D is going to become K. So K is going to be 0, negative 4. E is going to become the P, negative 3, negative 8. The F is going to become the R, so the R is going to be negative 6, negative 4. Then the G is going to become the Z. That's going to be negative 3, 0. So that's the Z. This is the R. And we connect that. Here is your image after a 180 degree rotation. List all the corresponding sides and angles. Well, angle D is congruent to angle K. Angle E is congruent to angle P. Angle F is congruent to angle R. And angle G is congruent to angle Z. The corresponding sides, DE is going to be congruent to KP. EF is going to be congruent to PR. FG be congruent to RZ. GD is congruent to ZK. Now we can look down and do another congruent statement. A congruent statement would be naming the first shape, maybe D, E, F, G, and the second shape has to be named in the corresponding positions. D went with K, E went with P, F went with the R, and G went with the Z. Our last set, the next congruent statement, it's asking us to write two of them. Often you'll just write one, but here we're pointing out that the order matters, so we're going to change this one up any way you wish. So I'll start with the F and then go to G and D and E. You need to go in consecutive order. You cannot jump through the shape when naming it. You have to go around in a circular pattern. It doesn't matter if you go clockwise or if you go counterclockwise. I went clockwise, starting with the F. So the F is supposed to correspond with the R, and then Z, K, and P. So some different topics that we've talked about today. All three transformations that we've done here, we've done a translation, we've done a reflection, we've done a rotation, does not change the size or the shape of our original transformation, and they are types of rigid motion. That means their size and shape does not change. Their orientation might. The angle that they're compared with might be pointing in a different direction. But after you do a transformation to it, the sides are still the same length. They don't grow or shrink. That'll be possible later on in the year when we talk about dilation. Two figures are to be congruent if all their sides and angles are also congruent.